Hello everyone, in this video I'm going to show you how to implement command line arguments for your Python programs. For those of you who may be still relatively new to using the command line, allow me to take a moment to explain what this is. Command line arguments are the extra bit of text that follows after the command itself. A good example is the package managers that we use on our Linux systems. For me, since I'm using Alma, I have to use the package manager yum or dnf. So if I type in dnf followed by install, install is the first piece of our command line argument because we are triggering the DNF functionality of installing a package. And what follows afterwards is the name of the package that we want to install. I'll just put in Python 3. It's already installed. I'm not actually going to run this, but I am typing it so you can see. So Python 3 is also part of our command line argument. Install is a keyword that tells DNF what it's going to do. It's basically telling DNF, hey, you're about to install something. And then we provide a list of package names or software that we want to install. In this case, that's Python 3. That's the data portion of a command line argument. And there's a bunch of different ways that command line arguments for software can appear. Some software have a bunch of keywords that we put in. Some of these keywords will have data values that need to be passed into them, and some of them won't. There's a whole bunch of them. And they come in many different forms. They can be keywords by themselves, often to act as an on-off switch for some settings. They can also be keywords that are followed by data values, like I showed you with DNF. They can also be just individual letters and work exactly the same way as full word arguments. You may also see them preceded by one or two hyphens, which I'll be referring to as tags in this video. Command line parameters can be used to tell a program how it should run as well as specify additional information for input values in the program. The latter is an incredibly useful alternative for user input, especially when the program is going to be run in an automated script. So the key thing that we need to start using argparse is simply to import argparse itself. But for this example, just to demonstrate everything surrounding command line arguments, I've also imported the sys module, which we're going to use to access a variable called argv, which you can see right here. Argv is a variable that will contain all of the command line arguments passed in to the program when it's run. Now, we don't have to import sys in order for this to work. Somewhere in Python, sys is already being imported and it's already created the argv variable. So we're only importing sys here so we can access it directly in our file. And one of the reasons I did that was to show you what Python does with the command line arguments once it loads up. I also have a little comment string here. This is our file's doc string, and we're going to use the doc string to help with putting together our argument parser to demonstrate one of the things that we can specify when we create our argument parser. So I create this variable here, parser, and we're going to store our argument parser object into it. So we call argparse.argumentParser, open pair of parentheses. Now, you can have just nothing in the parentheses. You don't have to fulfill any parameters to create this object, because everything that we would really need to get this to work comes after creating the object. But we can supply it with information if we so desire. And one thing I always fill in, which I would recommend to you guys to do too when you can, is to assign a value to your description. So this is where the doc string comes in. I just assign the magic attribute doc to the description, and it's going to take this in. You can also create a string variable at the top of your program that contains your description. It can have more information in it if you really need it to. But if you just want to keep things simple and your doc string is sufficient enough, it's not containing any nonsense, it's just describing what the program is, then you can put that in the description, no problem. There are other parameters here that might interest you. One is called epilogue. And what that does is that it adds this text that I'm putting in there at the end of the health message that appears if we use the -h flag when we try to run this program. Now, we don't have to specify the -h flag. It will take care of that for us. It automatically includes that whenever we use an argument parser. Some other things that we can put in there, I'm not going to include, but you can. We can specify our usage string. The usage string is basically what tells you how your program should be used. It'll basically be a very long string, including all the potential flags you can use and the values that you would need to pass into them, if any, to run the program. So that would also appear if you use the dash H flag or you input an incorrect argument. So, but I'm not going to put that in there. And there's a few other parameters you can fill out as well, but you're not often going to find yourself using those parameters. In fact, most of the time, you're probably only going to be using description. I very much doubt you would be using epilogue half the time. So after we create our object, we're going to add an argument. And to do that, we take our variable to reference our object, and we say parser dot add argument, and then we fill in some stuff. Now, this one, you need at least a minimum one value here, which is what your argument is going to be. And I specify it as an arg with a hyphen, and it's preceded with two hyphens. And then next, you can specify a type if you like. It's important to do so if you want the value you're passing in to be treated as something other than a string, because string is the default. And then we got our help message. Now, even though you only need this part to create your argument, I'd always recommend specifying the help string, because the help string should specify what the value this argument represents is. And then once we've defined all our arguments, we'll call the parser.parseArgs function. This will get the command line arguments we passed in when we ran this program, and it's going to parse them, finding all the arguments that should be there, and it will throw an error if it finds anything that shouldn't be there, or if maybe we passed in values that shouldn't be there, and it will store them into this variable here. And it's going to return a namespace object containing keywords that will reference our values that we passed in. And these keywords are actually going to be the same name as the arguments that we define here. So when I run this and I use the narg command line flag, it's going to create an attribute in the namespace object called an underscore arg. And the reason I say underscore is because hyphens cannot be in variable or function names or any kind of naming convention when you're coding in Python. So whenever it detects a hyphen here that's not one of the first two hyphens at the beginning of this, it's going to replace it with an underscore. We parse our arguments, we get our namespace object stored into args, and then I print out an arg, which is the attribute name in the namespace object, and it's going to print out whatever value I put in there. And then it's going to print out this message down here. And the reason I put this message down here is because I'm going to demonstrate what happens when you trigger an error with argument parser. So we've got Python cmd -arg01.py tac and arg with hyphen in the middle, followed by the value 123. So when I hit enter, so the first thing it prints out is the entire command minus the Python part, broken up into a list containing the name of the program we ran, followed by any command line arguments after that. So that's what sys.argv is doing. Then we print out the value of an arg, which you see right here, 123, and then we print out the message args parsed successfully. Now what happens if I print out something that's not an integer? Because as you can see here, I specified it has to be of type int. So let's type in test. We get this error here. So we still get the sysargv because that happens before it was parsed. But when we try to parse, it says, oh, you did something I wasn't expecting. And it will print out the usage followed by the error. And if I try to call narg without passing in any kind of data value for it, we still get an error because it's expecting one argument for that command line argument. And then if I run tac-h for help, it prints out all our information here. It prints out the usage. It prints out our doc string here, followed by all the arguments we can use, which in this case is just the optional arguments. And it tells you what flags you can use, whether or not they expect a value after the fact, and the description telling you what that flag is for. And then here's the little epilogue string that I specified here. So that only comes up when I use the -h flag. It doesn't actually come up with errors or anything like that. And you may have noticed that I had this other line here that was commented out. So I uncommented it and I commented the first one. So basically through Python, you can pass in your own list of arguments to get parsed by the parser. So all this is going to do is basically cut out the program name. It will still work. It doesn't necessarily need that part in order for it to parse the arguments. That just happens to be part of the sys.argv list. So it's basically going to work the same way. But the reason I'm demonstrating this is because this can be useful if you want to take a whole list of command line arguments and break it up in some way, and then split those different arguments up between different argument parsers with different argument parameters. The only reason I can imagine doing something like that is maybe you have a program that's very modular, it has plugins and stuff, and each of those plugins take in their own parameters if they're going to be used during a run. That's one reason I can think of to do something like that. However, I'm pretty sure there are plenty of other different examples that this can be useful for. So I would say it's still a pretty good idea to demonstrate this. So in order to pass in your own list of arguments through Python rather than just through the command line, just specify the parameter args, have it equal to the list that you want it to parse, and then just parse the arguments. And in this case, we're still using the command line string that we pass in when we run the program on the command line. We're just accessing it through sys.argv, and I'm just omitting the name of the Python file itself, which we're not really going to see that part because we're still going to print the sysargv beforehand, but you'll see that it still parses it even though we omit that first element. So I run it and see, still runs the same. And if we wanted to, we could put in our own list. So for the first element and arg, our second element, 456 in a string. I know that's weird considering it's expecting an integer, but the list of arguments, all elements have to be a string. Otherwise, it'll throw an error. See? Comes out just fine. So, and just to show you the error that you get if you try to just pass in an integer, because it's a understandable mistake to make. But just so you're not confused, and so you know what that error looks like, if I make that an integer instead of a string, if I run this, it throws an error because the integer is not a subscriptable object. So it doesn't like that. Okay, now we're going to go a little bit more in depth on how we can further specify how our arguments that we can add to our parser can work, primarily by specifying what parameters we want inside our add argument method. So the first one is pretty much the same as our last example. It's just a simple, straightforward argument. We've got a flag. It takes in one parameter, but this time it's a type string instead of a type integer, and it's got the help parameter specifying what it does. Then we have a second argument called taxc. We specify it as type string still, but then we add a new parameter called destination. Now, what destination does is that it specifies a different name for the attribute that the data we pass into this flag will be stored into. For example, like with Word, argument parser is going to create an attribute in namespace called Word, and that's what the data will be stored into. For taxc, instead of giving us a C attribute inside the namespace, it's going to instead give us a character attribute in namespace. And one other thing, because I'm sure there might be some people wondering what the difference between the two is. So the difference between a double tack versus a single tack is that double tacks are usually paired with full word parameters like word, whereas single tacks are often paired with single character parameters like C. So that's really all there is to it. I have seen some programs use single tack with full word parameters, but most of the time, in a lot of programs that I've seen, usually tack is for a full word, and one tack is just for a single character type parameter. We're going to specify word test and dash C capital A. So I'm just printing out the variable arg. So we're printing out the namespace object. So we see namespace and we've got word equals test and character equals A. Okay, now in this example, I'm going to be demonstrating two things. The first is the action parameter, which I will actually go into more depth in another example because there's a lot more actions you can assign than just store true. And we're also going to go over the required parameter. Now, let's start with the required parameter. If you recall from the very first example in this video, I said that parameters that usually have a tack, whether it's one or two tacks, before the name of the parameter itself, those are usually referred to as optional parameters. They're often treated as optional parameters, with some exceptions. This is one of those exceptions. We are specifying that this tack rec is required by setting required equal to true. So that's how you make this no longer a optional requirement. And then action is for when you want to have a parameter do something other than store data. Well, store data from the user. So in this case, we don't want the user to pass in something into the rec parameter. We don't want them to type something after the fact in the command line. We just want them to type tack rec. So we specify an action to tell Python how this should behave. In this case, we're saying store true. So rec will contain a value, but it's going to make sure it only stores the value that we want it to store, which in this case is true. So when I run it, namespace rec equals true. And just to see what happens when I don't have the flag, We get this usage explanation followed by the error explaining that we should have had the rec flag specified. Next up is the metavariable parameter. The metavariable parameter allows us to specify an alternative way to represent the values that have to be passed in after the parameter that we call in the help message. That's basically all it does, is it makes the help message look a little bit different, in some cases a little bit cleaner. In fact, to give you a better idea of what it's actually going to do, I'm going to delete this metavar real quick so you can see what it's going to look like when we don't specify the metavar. Then I'm going to run it with a -h flag. And so as you can see down here, as well as up here, so it's tac number followed by an all upper caps number to represent the placement of the value after tac number. So if we put the metavar back and then run it again, instead of number in all caps, it's just the letter N in all caps. And you can make it lowercase as well if you want to. It's really up to you. But that's what metavar does. It just makes your help message look a little bit nicer. And while we have it up here, you may have noticed positional arguments. So float does not have a tac or a single tac. It's just float. Argument parser treats this as a required positional argument. Even though I don't have the keyword required specified, because I don't have a single or a double tac, argument parser treats this as a required argument. Not only that, but you may have noticed on the screen here, it's just f. So we don't have to specify the parameter when there are no tags preceding the parameter name. We just have to put in the values that we want. So in this case, it's expecting a single float value. And this is also a good time to point this out, but as you noticed up here, tac h and tac number, they are surrounded in square brackets. That's also to indicate in the usage that these are optional parameters. However, f is not enclosed in square brackets, meaning it's expecting something for f. So if I try to run this without specifying anything after the fact, we get an error because it's expecting f, because f is required. So if I put in 12.2 and pass that in, we get a namespace where number equals none and float equals 12.2. Another parameter that we can specify for our arguments is in args, or number of args. And this is when we want to pass in a list of values into a parameter. And there are 4 settings that we can set for number of args. The first one is numerical. We specify a number telling it how many items it's expected to see when we call that parameter. So for tac names 1, I specify 3. So if I use tac names 1, I have to specify 3 names. For tac names 2, we have the question mark, which means we can optionally pass in a name or we can pass nothing in at all. And if we pass nothing in at all, it's just going to be set to none. And it's the only one out of the 4 here that's not going to store it into a list if we do specify a name. In tac names 3, we specify the asterisk. That means we can specify any number of values or no values at all. And even if we specify no values, it's still going to generate a list. It'll just be empty. For tac names 4, we specify the plus sign. Like the asterisk sign, that means that we can specify any number of values. However, we have to, at a minimum, specify 1. And I'm going to use a backslash here to have multi-lines so we can easily read everything. So slash. So for tac names 1, we'll specify Alice, Crow, and Ben. For tac names 2, we can either specify a name or not. Just to show how it works, I'm going to not specify a name, and then I'll run it again specifying a name. Tac names 3, again, we can either specify no name or we can specify any number of names. I'm going to not specify anything. Names 4, we have to specify at least 1. I'll specify Alex. And just so you're not confused or anything, the backslash has nothing to do with the code or the parameters or anything like that. That's just something you do with bash when you want to run a single command, but you want to type it out across multiple lines so it's easier to read what you're doing. So I'm going to hit enter. So names 1 has a list of Alice, Crow, and Ben. Names 2 is set to none. Names 3 is set to an empty list. And names 4 has a list with a single name, Alex. Now I'm going to go to names 2 real quick and specify Bill. And I'll specify something for names 3 as well. We'll say Sam. So names 1 still list of those 3 names. Names 2 is set to Bill. names3 is set to Sam inside of a list, and names4 is still set to Alex inside of a list. Now in this one, we're going to be looking at a handful of parameters, primarily the action parameter, but we're also going to be looking at the default parameter as well as the constant parameter. So the action parameter, as I mentioned earlier, is basically when we type in the flag, it's going to tell it to do something rather than passing in a data value. So we have store true, which I've demonstrated before. We also have store false, which is what the second one's going to do. We have store constant, which means we store a constant value inside of a variable. And we have store append. Now, store append is pretty interesting because it basically allows us to use a flag multiple times in a single command. And what it does is that every time it sees the flag being used, it will take the value that we assigned for each one and it appends it to a list. So when we actually print out namespace, instead of seeing multiple pilot variables, we're going to see a single pilot variable that's going to be assigned a list of values. So for debug, we're just storing true, nothing special there. We've already seen store true in action. However, we're specifying default. So default allows us to specify a value that it's going to have regardless of whether or not we use this flag. And default can be used in other situations too. We can use it for a flag that you would normally have to pass a value in. So say you have a flag that would take in a number, you can specify a default number if you don't call the flag and pass in your own number. Then we've got tac tac no verbose. Many of you will know the verbose flag for a lot of programs where it's basically saying, hey, print out more information so I understand what's going on step by step. I'm doing the exact opposite. I'm saying no verbose. We're going to set it to the destination verbose. We have it by default set to true, but we have the action to store false if we actually use the flag. Then we've got tac tac date. Now what tac tac date does is it's going to store a constant, and we specify the constant that's going to be stored if we use the flag by using the constant parameter. And in this case, I am calling date from the datetime module to store today's date. Then we got tac tac pilot, which is the append action. In this particular parameter, we will actually be able to use more than once, and it's going to basically take each value we pass into pilot and append it to a single list. So when we print out the namespace, we're going to see a single pilot variable with the list of all the values we passed into pilot. And then we've got a tac v and tac d, just like debug and everything, it just stores true. But this is to demonstrate that these flags are groupable. Python's argparse module has the built-in support so that you can group single character arguments together and it will still be able to parse them correctly. So I've specified VD as a single parameter as it looks like instead of a tac V followed by a tac D. We got tac tac debug, tac tac no verbose, tac tac date, and then we got two tac tac pilots where we've got crow and ben specified for both of them. So I run it. So debug right here, set to true. Verbose right here, set to false. Date, we have our date time object here. Pilot, we've got a single list containing both crow and ben specified in that list. And then we got V and D set to true because we got them right here. And just to demonstrate that date's only going to work if we actually use it, because const is not the same as default, you can see here that date is set to none. So const is not the same as default. And then finally, we have the parameter choices. Choices will allow us to restrict what will be put into a parameter. So I've got a parameter tac tac ship, and I've restricted the choices that we're allowed to pass in to frigate, cruiser, or capital. And just to show you what the help looks like when we have that. So we got tac tac ship, and then in curly braces, it's listing the three options we have that we can set it to. So if I specify tac tac ship, frigate, and we got namespace where ship is equal to frigate. If I try to specify something outside of those three choices, we get the error here saying that it's an invalid choice. We must choose from frigate, cruiser, or capital. argparse provides us the ability to group up our parameters. There are two different types of groups that we can create. The first is just a regular argument group, and the other one is the mutually exclusive argument group. Now, the basic argument group doesn't really provide a functional purpose. It just helps make our help messages look nicer. So in this example where we use the basic group, I've got two groups, pilot info and ship info. And then I group two arguments under both of them. They are specifically named something different because they will still collide with each other. that just because we're in different groups does not mean they're not going to collide with each other. But there's nothing really preventing me from using them both at the same time. So I've got pilot name and pilot ID set to crow and 1, 2, 3, 4 respectively. And then I have ship name and ship type set to hawk and cruiser respectively. So when I hit enter, all the information is right there. The second type of group, the mutually exclusive group, that is a bit more functional. It allows us to group arguments together that cannot be used at the same time. We've got a single group here, and we got two arguments, pilot name and ship name. They're both under the mutually exclusive group, so I cannot use both at the same time. If I try to, we will get an error. So if I run -h real quick, so the only visual difference in the help option, we don't really see anything down here, but it's up here in the usage. So we've got them both in the same set of square brackets. There's a pipe between them. That pipe is basically saying you can only execute one of these because they're in a mutually exclusive group. If you had 3 or 4, then there would be pipes between all of them, basically saying you can only choose one. So if I just specify pilot name crow, we get pilot name crow and ship name equals none. If I try to specify both, we get an error saying ship name is not allowed with the argument pilot name. The last thing we're going to talk about is a subparser. Subparsers allow us to group up arguments into specific groups. However, they are entirely different from the argument groups that I demonstrated in the previous example. When we use a subparser, we're not just separating parameters into different groups. We're making it so that we have to specify that subparser when we run the command, and when we do that, we're only able to access the arguments for that subparser. We can't use two subparsers at the same time, and one subparser cannot access the arguments from another subparser. In order to create a subparser, we call the method from our parser here, add subparsers, and we specify a destination variable for it, which I name command, and we store this object into a variable called subparser. We then use subparser to generate an actual argument parser using the argparse method. And for this one, I name the first one pilot with the help message add a pilot. And I store that into a variable called pilot parser. And then to add the arguments for that subparser, we reference the pilot parser to add the arguments. And I just specify tac name and tac ID. We don't have to worry about name collision between the two subparsers because we can only use one at a time. So I can specify tac name for both the pilot and the ship. I then specify a ship argument parser using the same subparser as before. So we add a parser, name it ship, give it the help message, add a ship, and then we add the arguments name and type. We parse our arguments like normal. And when we're doing subparsers, there's something we got to do a little bit different because it's not going to create all the attribute names in the namespace for all these arguments. It's only going to create the attributes for the subparser we use. So if I use the pilot subparser, namespace is only going to have name and ID. It won't have the name and type from this subparser. That's why we have to specify a value for destination in the actual subparser object, because then we can reference that attribute to see which subparser we called upon. Did we call upon pilot or did we call upon ship? And then based on that, we can determine which attributes we have to access to print our message on the screen. So first I'm going to show you what the help message looks like because it's a little bit different. So when I do a help message with just the program name, we get the positional arguments pilot and ship. That's all it shows us at the moment. If we want to see more information, then we have to specify the subparser. So I'm going to specify pilot, and it'll explain the parameters that we need for the pilot subparser. Likewise, if I set it to ship, it'll specify the parameters that we need for the ship. So pilot tac name crow tac ID 1, 2, 3, 4, 5, and we get crow 1, 2, 3, 4, 5. Ship name hawk type cruiser, and we get hawk cruiser. And that's about it for parsing command line arguments in Python. There are some other things you can do with the module, but they are a tad more advanced, so I just wanted to focus on the basic and most common uses for the argparse module. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.